Epinephrine versus norepinephrine, a comparative overview. Epinephrine and norepinephrine are two essential neurotransmitters and hormones that play crucial roles in the human body's physiological responses to stress, emergency situations, and overall homeostasis. While they share similarities in their functions and effects, they also exhibit distinct differences that make them distinct contributors to various bodily processes. Introduction. Epinephrine, also known as adrenaline, and norepinephrine, also called noradrenaline, belong to a class of molecules known as catecholamines. These molecules are produced and released by the adrenal glands and some nerve cells in the sympathetic nervous system. Functions and effects. Both epinephrine and norepinephrine play vital roles in activating the sympathetic nervous system and triggering various physiological responses. Epinephrine. Bronchodilation. Epinephrine relaxes the smooth muscles in the airways, leading to bronchodilation. This effect helps increase airflow into the lungs, which is beneficial during situations where quick and efficient breathing is essential, such as during physical exertion or exposure to allergens. Increased heart rate. Epinephrine acts on the heart by increasing the heart rate and the force of contraction. This enhances cardiac output, ensuring that oxygen-rich blood is pumped to vital organs and muscles, improving the body's ability to respond to stressors. Dilation of pupils. Epinephrine causes the pupils of the eyes to dilate. This allows more light to enter the eyes and enhances visual acuity, aiding in assessing potential threats or navigating through challenging environments. Increased blood flow. Epinephrine diverts blood flow away from non-essential functions like digestion and towards critical areas such as muscles and the brain. Norepinephrine. Vasoconstriction. Norepinephrine primarily acts on blood vessels, causing them to constrict. This narrowing of blood vessels raises blood pressure and maintains blood flow to vital organs even under stressful conditions. Moderate heart rate increase. While norepinephrine also affects the heart rate, its effect is generally less pronounced compared to epinephrine. It supports maintaining an adequate heart rate to sustain blood flow without causing excessive strain on the heart. Enhanced mental alertness. Norepinephrine's actions in the brain contribute to increased mental alertness, focus, and heightened attention to surroundings. This effect aids in making rapid decisions and responding appropriately to threats. Stress response regulation. Norepinephrine is involved in regulating the body's overall stress response. It helps modulate the release of other hormones and neurotransmitters, contributing to a balanced response to stressors. Key differences. Target receptors. Epinephrine acts on both alpha and beta adrenergic receptors, leading to a broad range of effects on various organs and systems. Norepinephrine primarily acts on alpha adrenergic receptors, emphasizing vasoconstriction and blood pressure regulation. Systemic versus local effects. Epinephrine has more systemic effects due to its broader receptor activation, influencing multiple organ systems simultaneously. Norepinephrine's effects are more localized, particularly on blood vessels and the heart. Heart rate increase. Epinephrine significantly increases heart rate, making it a crucial factor in boosting cardiac output during extreme stress or physical exertion. Norepinephrine's heart rate effects are more moderate. Blood pressure. Norepinephrine's potent vasoconstrictive effects contribute to a more pronounced increase in blood pressure compared to epinephrine. Mental effects. Norepinephrine has a more notable impact on mental alertness and focus, enhancing cognitive functions, while epinephrine's effects are more generalized. Clinical applications. Epinephrine. It is commonly used in emergency situations like anaphylaxis, where it rapidly reverses severe allergic reactions by dilating airways, increasing blood pressure, and preventing further release of inflammatory mediators. Norepinephrine. In critical care settings, norepinephrine is used to treat severe hypotension, low blood pressure, and shock.